The diameter of Earth is approximately 12,742 kilometers, or 7,918 miles, and this is an average value. If measured from pole to pole, known as the polar diameter, the figure might be slightly larger. This is one of the fundamental parameters indicating the size of our planet. Earth rotates around its axis in a motion known as self-rotation. Here is a description of how Earth performs this motion. Axis of rotation. Earth is considered a sphere, and its axis of rotation is an imaginary line that passes through each point on the surface of Earth and the planet's center. This axis is referred to as the Earth's axis. Self-rotation motion. Earth undergoes self-rotation around its axis. The rotation direction is from west to east. Rotation speed. At the surface, Earth completes one full rotation approximately every 24 hours, defining a day. This time is divided into 24 hours, each hour into 60 minutes, and each minute into 60 seconds. Coriolis effect. The rotational motion of Earth creates the Coriolis effect, causing objects moving on the Earth's surface to exhibit a tendency to deflect to the right in the northern hemisphere and to the left in the southern hemisphere. Influence on seasons and day-night cycle. The self-rotation also contributes to the phenomena of seasons and the alternation between day and night. Regions facing the sun directly experience longer days, while areas farther away experience longer nights. Earth's self-rotation is a crucial factor shaping the environment and living conditions on the planet. The Earth's atmosphere is divided into several layers primarily based on temperature variations and chemical composition. The general characteristics of these layers from the bottom up are: troposphere. Location, from the surface up to approximately 8 to 15 kilometers, varies with geographical location and season. Features: this layer contains most of the atmosphere and is where most weather phenomena occur. Temperature decreases with altitude in this layer. Stratosphere. Location, from about 15 kilometers to 50 kilometers. Features: temperature increases with altitude here due to the presence of the ozone layer. This layer plays a crucial role in protecting against the impact of UV rays from the sun. Mesosphere. Location, from about 50 kilometers to 85 kilometers. Features: temperature decreases with altitude in this layer. This is where objects from space begin to interact with the atmospheric layers. Thermosphere. Location, from about 85 kilometers to 600 kilometers. Features: in this layer, temperature increases significantly due to the influence of UV and X-rays from the sun. This layer contains high-energy molecules and atoms. Exosphere. Location, from about 600 kilometers and above. Features: this layer can be considered the outermost boundary of the atmosphere, where low-mass molecules and atoms can freely escape Earth and enter space. These atmospheric layers experience different temperatures, pressures, and chemical compositions, contributing to the diverse dynamics of Earth's atmosphere. The core structure of Earth is primarily composed of two main components, the inner core and the outer core. Here is a detailed description of the Earth's core structure. Inner core. Material: it consists mainly of iron and nickel, but due to high pressure and temperature, it exists in a solid state. Characteristics: the temperature at the inner core is estimated to be up to around 5,700 degrees Celsius, 10,332 degrees Fahrenheit. The pressure here is also immense, creating conditions for iron-nickel alloys to exist in a solid state. Outer core. Material: similar to the inner core, the outer core also primarily contains iron and nickel. However, in this layer, they exist in a molten state. Characteristics: the temperature here is high, around 4,000 degrees Celsius, 7,232 degrees Fahrenheit. The fluidity of the material generates the flow of hot liquid, creating electrically conducting currents and generating the Earth's magnetic field. Mantle. Material: This layer is situated between the core and the Earth's crust and is composed of minerals such as silicates, oxides, aluminum, and iron. Characteristics: the mantle is further divided into the upper and lower mantle and contains a significant amount of molten material, contributing to phenomena such as tectonic movements and volcanism. The core structure of Earth not only determines the planet's properties and dynamics but also has a significant impact on Earth's magnetic field through the dynamo effect, where the movement of electrically conductive material in the outer core generates a powerful magnetic field that protects the planet from solar wind and preserves Earth's ozone layer. There are many large mountain ranges on Earth, and the specific number depends on the definition of a large mountain range and the specific geographical scope. However, here are some widely recognized large mountain ranges. Andes Mountains. Location: South America. Features: the longest mountain range in the world, spanning across 7 South American countries. Rocky Mountains. Location: North America. Features: stretching from North America to South America, creating a large mountain system. Himalayan Mountains. Location: South Asia. Features: include several of the world's highest peaks, such as Mount Everest. Alps Mountains. Location: Europe. Features: renowned for their natural beauty, often considered one of the most famous mountain ranges globally. Caucasus Mountains. Location: between Europe and Asia. Features: connects Europe and Asia, forming a natural border between these two continents. Great Dividing Range. Location: Australia. Features: the main mountain range runs along the eastern part of Australia, creating an underwater divide between high and lowland areas. These are just a few of the large mountain ranges, and there are many other mountain ranges on Earth with unique characteristics and locations. The movement of frost algae can influence the topography of the soil through a process known as cryoturbation. Here is how frost algae movement can impact soil environments. Frost algae, cryoturbation. When water in the soil freezes and frost algae form, this frozen water can expand and create strong pressures, increasing the pressure within the soil. The expansion and high pressure can induce the movement of soil particles, water, and the frost algae within the soil. Landform formation. The movement of frost algae can create unique structures within the soil, known as cryoturbation features. Cryoturbation features include frost boils, straight stripes combined with ice, and patterns of accumulated soil due to the movement of water within the soil. Impact on soil. This movement can affect the structural integrity of the soil and the distribution of different soil types. It can create visually striking patterns on the soil surface, influencing the slope, shape of plains, and other characteristics of the soil. The movement of frost algae contributes to the soil formation process, and this can be particularly significant in cold environments, such as tundras and polar regions, where frost algae are commonly present due to freezing water. Earth has diverse landscapes due to the influence of various natural factors and geological processes that have occurred over billions of years. Below are some key factors contributing to the diversity of landscapes on Earth. Tectonic forces. Tectonic movements, internal forces, such as the pushing and pulling of Earth's crustal plates, create diverse features like mountain ranges, valleys, and rifts. Water influence. Erosion. Water flow, ocean waves, and rainfall lead to erosion processes, forming valleys, hills, and plains. Flooding and rivers. Flooding and river flow contribute to carving out deep channels and forming waterfall systems and river valleys. Geological forces. Volcanic activity and sediments. Volcanic activity creates mountain peaks, while sediments can contribute to flat landscapes like plains. Impact of water bodies. Lake formation. The excavation of lakes and water bodies contributes to unique landscapes such as lakes and lake valleys. Geological forces. Landslides and earthquakes. Geological events like landslides and earthquakes can alter landscapes, creating slopes and fractures. Human impact. Urbanization and agriculture. Human activities, such as urbanization and agriculture, can modify natural landscapes and create structures like cities, farmlands, and rural areas. Climate changes. Glacial and ice influence. Changes in temperature contribute to the formation of landscapes like glaciers, ice caps, and snow-covered plains. The combination of these factors results in a diverse array of landscapes across Earth.